So, yesterday's example you did?
Yes, ma'am.
Yes,
There is
ma'am.
no problem.
Yes, ma'am.
मैम सेकंड वाला नहीं है.
Second,
सेकंड येत नाही मॅडम.
हाँ.
आन्सर येत नाही त्याचं.
कुणालाच नाही येते.
आया ना मैम.
आया ना? जिसका आया होगा
हाँ,
ना
आया।
उन्होंने सब पे डाल दो वो.
ओके मॅम.
कौन हिना बात करे? कौन बात करे? किसका आया है?
बिस्मा मैडम.
बिस्मा. हाँ.
बिस्मा.
तो आप व्हाट्सएप पे डालो. किसी को प्रॉब्लम होगा ना तो देख सकते हैं.
ओके मैम.
दोनों. और पहले वाला तो ये ऊपर वाला जैसे ही है ना, फर्स्ट वन हमने जो किया वो TC2 पहले
हाँ,
लेना है, बाद में TC7 फिर TC5 था, तो इंस्टेड ऑफ 5 वो 7 करके सॉल्व करना था उसको. Okay, so I suppose everybody did it. Now we will go to next section. Lecture 11. Okay, so in this section, we will assume that our domain of YT is consecutive integers. Okay, I will write also it is in or throughout this section. Okay. Throughout this section, we assume that domain of YT as set of consecutive integers. Integers, say in particular n is equal to 1, 2, 3 and so on. Okay, so now in this section we will assume that our domain of YT is set of natural numbers. Means domain is 1, 2, 3 and so on. Okay, my T is 1, T plus 1 is 2, T plus 3 is 3 and so on. Okay. So whatever if I take summation, then whatever C of T I will get, that will be constant. Okay, just constant it will be. Now and as we are considering domain of YT as set of natural numbers, I can consider YT as sequence. YT can be considered as sequence. What is sequence? Sequence is a function whose domain is set of natural numbers. Right? So YT I can consider as sequence. Okay. Where n belongs to n. N belongs to n. Now also we will use the convention. Also we use the convention summation k is equal to a to b, yk is equal to 0 whenever a is strictly greater than b. Okay, when a is strictly greater than b, then summation, whatever summation we are taking, that finite sum, that we will consider as 0. Usually we write summation as like increasing points, na? So when my starting point is if strictly greater than b, then this summation will be 0. Is that clear? Is that clear? we will assume that summation a to b yk is equal to 0. That is the like convention we are using. Okay, and yk is my sequence. Now consider consider the following. Okay, now for fixed m, and when n is greater than equal to m, what will be delta n of summation k is equal to m to n minus 1 yk? Can anybody tell it this? What is delta n? Because here k is involved, m is involved, n is involved. So I am writing particularly delta with respect to n. Suffix is n.
Summation k runs from m
Yeah.
to n minus 1 plus 1 yk.
K is equal to m to n. N will be replaced by n plus 1. So n plus 1 minus 1 will be just n. Yk minus function as k is equal to m to
n minus 1 yk.
What will remain?
Yk?
Yk.
Yn.
Yn. Last term will remain, na? Only last term will survive, remaining will cancel each other. Okay. So only yn. Okay. And for fixed p, where for fixed p and p greater equal to n, what should be delta n summation k is equal to n to p yk? What should be this? It is summation k is equal to n plus 1 to p. P is fixed. Yk minus summation k is equal to n
from
p
n to p
yk. So what will remain?
Yn plus 1.
Yn plus 1. Which term will survive here?
Y.
Y. Only y?
Yn.
Yn.
Y1, ma'am.
Yn. Only yn?
Yn plus 1, no, ma'am.
Yn plus 1.
You can simplify this. What will be this? I will write yn plus 1 plus yn plus 2 plus and so on yp. Last term is yp, right? Last term is yp minus, what is this? Yn plus 1 plus yn plus 2 and so on. What is last term? Yp. So what is remaining?
Yn.
Yn plus 1,
Yn.
yn plus 1, yn plus 2, yn plus 2, they are all getting cancelled. Only minus yn. Minus yn is surviving. Is that okay?
Yes, ma'am.
Yes, ma'am.
Yes, you can consider that. Okay. So you can see the difference here. In first summation, m is fixed. Okay, lower limit is fixed, and in above below summation, p is fixed. Upper limit is fixed and we are varying n. Okay, here we are varying n. N2, yes, N2 it is. So what I am getting? So delta, so I got delta n summation k is equal to m to n minus 1 yk is nothing but yn. Right? So what can I say for fixed m? And n is greater than equal to m. I got this one. And or so what can I say? Summation k is equal to m to n minus 1 yk is nothing but summation
Yn.
indefinite integral, not integral, indefinite sum yn is nothing but this one. If I take anti-summation on both sides, anti-summation delta will get cancelled. So this original function will be as it is, and this is indefinite sum yn plus c of t, where delta c of t is 0, but my domain is, since natural numbers, it will be just constant, where c is arbitrary constant. Is that okay? Taking summation on both sides, I can write here, taking summation on both sides, like how we take integral. Okay, both sides, we get this one. So I will this is for m less than or equal to n. Okay, this is when m is less than or equal to n. I will call this equation as 2.2. 2.1 is different, 2.2. And also we got what is delta n of summation k is equal to p to n to what is that, n to p, n to p, n to p yk. What we got? It is minus yn, right? We got minus yn, where p is greater than equal to n. So again, summation on both sides, taking summation on both sides, what we will get? Summation k is equal to n to p yk is nothing but anti-summation minus yn plus some constant, right? Is that right? Or I can write this as let me write here also, summation yn I can write. Okay, now in 2.2 you can see I want indefinite sum yn. So I will take this indefinite sum yn to LHS, and this I will take to RHS. And since this is arbitrary constant, so if I write, okay, I will erase this, or I will write again. This instead of 2, this is not my 2.2. And from here I can write, first I will write this one, summation yn is minus summation k is equal to n to p yk plus some constant d, where p is greater than equal to n. And Is that okay? How I written this? This also can be written as like this. This summation yn minus, I taken this side, minus yk, and plus that constant will become, since that is arbitrary constant, I can write as plus d. Is that okay?
Yes, ma'am.
C dash or C1 also you can say, where C dash is arbitrary constant. Arbitrary constant. So I will give this as 0.3, and this I want to rewrite it. So that I can rewrite as summation yn is equal to summation k is equal to m to n minus 1 yk plus c. Can I write like this? When m is less than or equal to n, and I will give this as 2.2. Can I write like this?
Yes, ma'am.
C is arbitrary constant, so here you can take C1, and here you can say C. Okay, no problem. तुम्हाला वाटत असेल तर इकडे मायनस, इकडे गेल्यावर त्याला मायनस C1 होईल, but minus C1 you can consider as some another constant C, capital C. Okay, so I can write this. Is that okay?
Yes, ma'am.
This is important 2.2, and this is also important 2.3. So can you see this 2.2 and 2.3 tells us something like finite sum and indefinite sums are related to each other with these relations 2.2 and 2.3. Okay, so here 2.2 or here from equations 2.2 and 2.3, we observe that definite sum and indefinite sum are related. Indefinite sums are related with the relation mentioned in 2.2 and 2.3. Is that okay? This is my finite sum. K is equal to n to p. This is finite sum, and this is indefinite sum, summation yn. It is indefinite sum. Is that okay? So we are having a relation between definite sum and indefinite sum are related. So now using that relations, we want to compute the definite sum. So take example, or before, okay, before going to this, we will have some theorem first. Theorem. Analogous result, we can say analogous result to the fundamental theorem of calculus. What is fundamental theorem of calculus? This theorem is analogous result to fundamental theorem of calculus. What is fundamental theorem of calculus? Can anybody recall it? I will write the statement of this theorem and you can recall up to that. If Zn is an indefinite sum of yn, then summation finite sum k is equal to m to n minus 1 yk can be written as zk m to n. This can be written as zn minus zm. Can anybody recall what is fundamental theorem of calculus?
Integration of f of x
Integration
from
of
a to b is equal
a to
f
b
of x.
f of x
F is equals to
x,
dx is equals to f of b minus f of a.
capital F of b minus f of a.
Capital.
What is capital F, small f, or here small f? What is the relation between? Are you saying this f and this f should be same, or some relation?
Relation.
What is relation?
F dash of x is capital F dash of x is equals to small f of x.
Capital
F dash of equals to small f of x.
capital F means f of x is equal to integral fx. Is it? You write like this. This is also fundamental theorem of calculus. F dash of x dx integral a to b is fb minus fa. What is relation between this f and this f? आता सांगू शकतात का? What is the relation? This is same as saying this, right? But so can you say now what is capital F and small f?
Antiderivative.
कोणाचा?
Yes, antiderivative.
Anti derivative. This is f, no? What is this? If here f dash, here we are getting integral.
Relation between derivative and integration.
It will be original function f. So इथे काय यायला पाहिजे? इथे f असेल तर इथे काय पाहिजे? इंटिग्रल f. इंटिग्रल घेतल्यावर जे काही फंक्शन येईल तो ना.
Yes, ma'am.
So capital F is equal to what?
Integration of small f.
Integration of small f.
Integration of
Small f.
small f. Yes. So is that correct? So is this and this is same? Why are you taking that much time? This is indefinite integral, na? Capital F is indefinite integral. Of small f. Right?
तुका ए तुका
Is that clear?
Yes, ma'am.
Yes. So I will just erase this. So so this theorem, whatever we have written, is analogous result to fundamental theorem of calculus. If Zn is indefinite sum, Zn is indefinite sum. तिथे काय होतं? Capital F is an indefinite integral of small f. Then we get integration a to b f of x dx is equal to capital F of b minus f of a, right? That is a or I will write here fundamental theorem of calculus. If capital F of x is an indefinite integral of small f of x, okay, small f of x, then integral a to b small f of x dx is nothing but capital F of b minus f of a. Is that okay? So this is definite sum yk is equal to summation zk, where zk is indefinite sum of yn. So I can write this as zn minus zm. Is that okay?
Yes, ma'am.
So this is just for your information. Now I want to prove this theorem. How I can prove this? I have 2.2. What is 2.2? Summation yn is this one, right? Indefinite sum yn is nothing but relation between indefinite sum and definite sum. So what is from 2.2? We have what we have? Summation yn can be written as summation k is equal to m to n minus 1 yk plus c, where m is less than or equal to n. Right. So if this is my Zn, this is my indefinite sum, na? This is my Zn. Zn is indefinite sum of yn, right? So this is my notation Zn. So what will be Zm?
Summation ym.
Summation ym.
Yn.
Will be this k is equal to m to m minus 1 yk plus c. So, but here, what is the relation? M is greater than m minus 1 usually.
Yes,
M
ma'am.
minus 1 छोटा है ना. So whenever my
Yes,
A is strictly greater than B, this sum is 0 only. This is we just first line only. We use the convention summation k is equal to a to b yk is equal to 0 whenever a is strictly greater than b. In this summation, my m is strictly greater than m minus 1.
Yes,
Yes,
ma'am.
ma'am.
Yes, so I can write this as 0.
Yes, ma'am.
Yes, this is nothing but 0, right? So what will be? So therefore, so this implies what is Zn minus Zm?
Zn Zn.
K is equal to m to n minus 1 yk plus c minus c will get cancelled, right? Or shall I write this is plus c minus summation k is equal to m to m minus 1 yk plus c. But as since this is 0, what I will get only summation k is equal to m to n minus 1 yk. This is my zn minus zm. That only I want to show, right? If zn is indefinite sum of yn, then I want to show k is equal to m to n minus 1 yk can be written as zn minus zm. Is that okay? That is summation k is equal to m to n minus 1 yk. I can write as z k running from m to n means zn minus zm. Is that okay? So it follows from directly 2.2. From 2.2 we have this one zn. So I can write zn is equal to this, but this will become 0 because lower limit is strictly greater than upper limit. Okay. So zn minus zm will be this one, and since this is 0, I will get only this term. C and C will get cancelled, or arbitrary constant. So I get this one. Is that okay? Is that okay?
Yes, ma'am.
Yes, ma'am.
So how you will start if you want to write the proof for fixed m and n greater than equal to n, delta n, k is equal to m to n minus 1 yk is nothing but yn. So taking summation on both sides, I will get this. So 2.2. Okay, I have directly written here from 2.2 we get. Okay, so you have to start with like that. That 2 lines also you have to write. Which 2 lines? This. Okay, this you have to write for fixed m and n greater than equal to m. We are having this one. Is that okay? Okay, now we will come to the example. Example 2.7. Compute the definite sum summation k is equal to 1 to n minus 1 2 by 3 raised to k. We want to compute this sum, definite sum. So from 2.2, which I can use, this 2.2 I can use, this finite sum I can write in terms of indefinite sum, right? I can use this one, either this or this one. Can I write?
Yes, ma'am.
So from 2.2, we have what we have, summation k is equal to m to n minus 1 yk is nothing but summation yn plus c. Now I am writing this c this side because I want to calculate this. Okay, so 2.2 either you so this relation I am using. Okay, either this or this 2.2. So definite sum in terms of indefinite sum or indefinite sum in terms of definite sum. So now in this example I want to calculate definite sum. Okay, I want to calculate k is equal to 1 to n minus 1. I want to calculate as definite sum. So definite sum I am writing in terms of indefinite sum. So what I will get? We have this. Therefore, what can I write? Summation
Summation K
into
n minus 1.
n minus 1 2 by 3. What can I write?
Summation 2 by
2 by 3 plus c.
3.
Yk is 2 by 3 raised to k. Kth term. Yn is 2 by 3 raised to n. Then, is it? Kth term is 2 by 3 raised to k. So, nth term will be 2 by 3 raised to n. Is that clear?
Yes, ma'am. Yes, ma'am.
Yes. Now, what is some indefinite sum of 2 by 3 raised to n? What is summation a raised to t?
A raised to t upon a minus 1.
A raised to t upon a
A
minus
minus
1. Right? This we have already proved in theorem. So from theorem, whatever may be the theorem, that 2.5a, I think 2.5a. Yes, it is 2.5a. Theorem 2.5a. We have this. Okay. Plus some constant c. So what can I write here?
2 by 3 raised to n divided by
2 by 3 raised to n divided by a. A is 2 by 3 minus 1
1 by
plus constant. Ha constant plus constant. So I will just write c. तुम्ही त्याला c1 plus c plus d असं म्हटलं तरी चालेल, but it doesn't matter if you add that is arbitrary constant only. Okay, this plus c is from here. This again one c will be there. That c and that c I am writing it just constant c. Okay, हे कळतंय का?
yes, ma'am.
Yes. So there is no harm if I write here c1, then here plus c, and then c1 plus or c1 plus c2 is equal to c. Also no problem. So what I will get here?
Two by 3 raised to n divided by minus 1 by 3
And divided by
minus 1 by 3
minus 1 by 3. So I can write here minus 3
minus 2
and plus some constant. What is n? N is equal to 1. What is n here? N will be n can't take one value because my n is strictly greater than m. M is my 1. So I my n running from 2 to. Is that okay?
Yes, ma'am.
3, 4 and so on. So this is my summation. K is equal to 1 to n minus 1 2 by 3 raised to k. Now I want to find this c. So for n is equal to evaluate c, value of c, put n is equal to 2. What I will get here then? Summation k is equal to 1 to 2 minus 1. 2 by 3 raised to k is equal to minus 3. 2 by 3 raised to 2 plus c. Is that right?
Yes, ma'am.
Here I am